Hello everyone, in this video I am going to discuss about lattice energy. In order to understand lattice energy, let us take an ionic compound NaCl. Okay, NaCl, this is the solid form. How this NaCl is formed? Okay, this NaCl is formed when Na plus in the gaseous state and when Cl minus in the gaseous state combine together to form NaCl. Okay, to form NaCl. But this Na plus, any element or any atom with plus sign is with charge is very unstable. Cl has charge, so this is unstable. Everyone like to become stable. Every elements like to become stable. So when they are brought close to each other, they will try to combine because there is some attractive force between the positive and the negative charge particle. So they will try to combine each other to become or to form a stable compound. This is your stable compound. Okay, so this, whenever it is forming a stable compound, it has less energy. So in going from this part, that means reactant part, to the product part, some amount of energy is released, and that energy released to form 1 mole of this ionic compound from its constituent ions, that is positive charge and negative charge, that energy released is called your lattice energy. So what is lattice energy? Lattice energy is defined as the amount of energy released. How it is released? Why it is released? When 1 mole of ionic compound is formed from where? From the constituent oppositely charged particle. So some amount of energy will be released because this compound has less energy than this, and that is why it is forming a compound. So that energy released is called your lattice energy. Or in other word, we can also say that this NaCl can also be separated into their constituent ions. Okay, separated into their oppositely charged ion. How? NaCl is a stable compound. So in order to break this stable compound, some amount of energy will be required. That energy required to break or to separate this stable compound into its constituent ions or into its constituent oppositely charged particle is called your lattice energy. So in order to break, energy is required. In order to form compound, this called energy is released, and both two can be defined as lattice energy. Okay, so lattice energy cannot be defined directly. We can understand lattice energy with the help of Haber cycle. Okay, in the Haber cycle, okay, I'm going to show you here. So Na in the pure form, okay, that is solid form, Na generally remain in the solid form, and Cl2, chlorine generally remain in the gaseous form. It will form into NaCl. Okay, so this formation is called heat of formation. Since Cl is 1 here, in order to balance it, we have to put here half so that it becomes balanced. Okay, 1 each. Now we will go through certain changes of energy in order to bring the Haber cycle. Okay, so Na is the solid form. Let us convert it into gaseous form. So in order to convert from the solid state to gaseous state, some amount of energy is required, and that energy is called sublimation energy. Plus sign indicates that energy is required or energy is absorbed in converting from solid to gaseous state. Okay, now this sodium will again change into the sodium ion, also in the gaseous state. For that ion, okay, it will change into ion. For that also we require some amount of energy or absorb energy. That is why it is indicated by plus sign. Absorb or required is plus. So this energy is called your ionization energy. Okay, so in this way Cl2 will change into their gaseous atom by dissociation. This Cl2 Cl bond Cl should be broken, so that is called dissociation energy. Okay, so some amount of energy will be required. Next, this Cl will change into Cl minus of the gaseous state by releasing some energy, and it is called electron affinity. Okay, while converting from Cl to Cl minus, some amount of energy will be released, and that is called your electron affinity. And after all, at last it will form into this Na plus in the gaseous state and Cl minus in the gaseous state, plus ion minus ion, will now convert into Na solid, and some amount of lattice energy will be released, and it is minus U. Okay, minus represents some amount of energy is released, and in order to convert from this ions into this, some amount of energy is released, and that is called lattice energy. Okay, now S is called your sublimation energy. Okay, S is your sublimation energy, D is your dissociation energy, IE is called ionization energy, and EA is the electron affinity, U is the lattice energy, delta HF is the heat of formation. So let us calculate delta HF. Okay, so how is delta HF formed? So we will go through heat of sublimation, we have to go through all these changes. Then what? Then ionization energy, this ionization energy. Okay, then what comes? Then also dissociation energy. Okay, dissociation energy. Okay, then in this case it is half, so we will put half. Okay, in this case since it is half, so half dissociation energy. Then the electron affinity is minus sign, then lattice energy is also released, so it is minus U. So this is the enthalpy of formation. Okay, so plus sign indicates for energy absorbed, minus sign indicates for energy released. Okay, let us learn now high lattice energy. How do you know this compound has high lattice energy? That means if the compound is having high lattice energy, that means they are forming a very stable ionic compound, high lattice, because there is very strong attractive force between them. So stability of the ionic compound shows that high lattice energy. So high stability of the compound. High stability of the compound means what? Greater attractive force, because there is so stronger attractive force that it becomes stable compound. So again, greater attractive force between the ion means there is a strong bond between them. So melting point, in order to melt it, high amount of energy should be supplied. So melting point is high and boiling point is also high. Again, lattice energy is directly proportional to is inversely proportional to the size of the ion. That means we require the size should be small. So NaCl and KCl. Now this Cl part is same, just keep as it is. Now we will consider differences here. Na and K. Na is plus, K is plus. Which one is having more size? This one is having more size. Which one is having less size? This one is having, sodium is having less size, because in the periodic table sodium, then comes potassium. So smaller the size, more is the lattice energy. So NaCl will have more lattice energy, because lattice energy is inversely proportional to the size. So less size, more energy, more size, less lattice energy, inversely. Okay, lattice energy is directly proportional to the charge on the ions. Okay, let us take this one, Al2O3, Aln. So aluminum have same metal, so we will take the different one. Oxygen has charge how much? -2. Nitrogen has charge how much? -3. So which one is having more charge? That will have more lattice energy. So this will have more lattice energy. Okay, now KCl and KBr, here K same. Now we will take upon the charge is also minus, so we will not consider charge since they are same. We will consider the size. So which one is having bigger size? So bigger size means inversely less lattice energy. Less size means having more lattice energy. Okay.